Good day, Mr. Bahado, and to my fellow viewers. I hope you're doing fine in this type of weather. My name is Jeremiah Felipe, and I'm here with my co-reporters to cover this very lesson. Our main topic today is feathering constant speed propellers. And the first part will be discussed by Karl Dalus.
Constant speed propellers in an aircraft fitted with a variable pitch propeller. The pitch control lever controls engine RPM and the throttle controls manifold air pressure. The system utilizes a constant speed unit and a pitch change mechanism to maintain the RPM set by the pilot. Constant speed units on speed, sometimes referred to as propeller governors, are normally fitted to the front of the engine and will incorporate a geared boost pump to provide the pitch change mechanism with high pressured oil. The CSU utilizes flyweights which are rotated to propeller controlled by the engine and are object to centrifugal force which tends to make them fly. They are prevented from doing so by the speeder spring. The pilot set the tension on this spring via the pitch control lever. If the system is maintaining set RPM, the pilot valve will maintain pressure in the propeller hub. This is known as on-speed. Constant speed units underspeed. If the RPM tries to decrease underspeed, the flyweights will fly inwards and open the pilot valve, allowing high pressure oil to travel to the pitch change mechanism, decreasing the blade angle. As the RPM begins to increase back to the selected RPM, the pilot valve will close until the system returns to the on-speed. Constant speed units overspeed. If the RPM tries to increase overspeed, the flyweights will fly outwards and raise the pilot valve, allowing oil to return to the some increased blade angle. As the RPM decreases back to selected RPM, the pilot valve will close until the system returns to the on-speed condition.
Pitch change mechanism. The most common is the use of hydraulic piston. Centrifugal twisting moments are used to assist in moving the blade to fine pitch. This is often augmented by the use of spring, counterweights, or nitrogen charges. Typically, engine oil is used as the hydraulic fluid as is boosted to the requirement pressure via a pump in the system. An increase in pitch is required. The CSU pumps high pressure oil into the cylinder and the piston passes the blade via mechanical linkage. When a decrease in pitch is required, pressure is released by the CSU and oil is allowed to return to the sump as the centrifugal twisting moment moves the blade to the fine position. Here the piston is fixed and the movable dome causes the blade pitch. Again, to find the blade, the CSU will release the oil pressure and the blade will fine via the centrifugal twisting moments. This system can be seen as the opposite of two previous two. A counterweight is introduced which is offset from the pitch change axis. This counterweight is used to coarsen the pitch. The hydraulic system is used to move the blade to fine position.
Feathering systems. A windmilling propeller will produce drag equal to a disk of the same radius in a twin-engine aircraft. This excess drag will cause a yaw and rolling moment towards the failed engine. Depending on the airspeed and power produced by the live engine, the rudder may not have enough authority to overcome this. The type of feathering system depends on the type of pitch change mechanism that is led. A large number of aircraft incorporate an auto feathering system. In some aircraft, the aircraft must be feathered before the RPM drops below a certain value. Beyond this, the feathering system will not be able to overcome the combination of centrifugal and aerodynamic twisting moments. That is all we have to cover in this video lecture. I hope that this lesson is comprehensible and taught you more on the feathering constant speed propellers. Thank you for sticking with us and good luck with your studies.